NestJS is a framework for building flexible, well-architected web apps, APIs and microservices using NodeJS. You can use either JavaScript or TypeScript to code your Nest projects. It's crammed with features that make it really easy to build any kind of web service or application you'd like. It also includes a very useful CLI or command line interface, and in this video I'll show you how to use the CLI to create a new project and then walk you through the different parts of the Nest template project, explaining the purpose of each part as we go. Let's get started. Before we start, we need to make sure that the Nest CLI is installed. Head to a console and run the command npm install -g nestjs/CLI. To create a project, run the nest new command and then specify the project name. In this case, let's call it first Nest project. The default language for Nest is TypeScript, but at this point, if you wanted to use JavaScript, you could do so by adding the parameter --language.js. We're now prompted to choose our package manager, npm or yarn. I'm old-fashioned, so I'll choose npm. And that's it, our Nest project is ready. By default, Nest installs all package dependencies when creating a project, so you don't need to run npm install afterwards. Let's change directory into the newly created folder, and we can run the project straight away with npm run start, or if you like, nest start. In our browser we see a hello world message. So let's go have a look and see how it was done. Here we have our Nest project open in VS Code. The CLI has created all the files we need to run, develop, build, test our code. This includes a tsconfig file which allows us to use TypeScript when developing our app, a gitignore file, we have a empty git repository so we can push this to source control when we're ready, and we have a test folder which contains our unit test runner. All of our source code is contained in a source folder. At this point, let's have a look at the three main components of any Nest project. First, we have modules. Modules are the architectural building blocks of a Nest project. They provide a useful way to organize your code and group together related features. For example, you might have a user management module and a separate one to manage product endpoints and services. Next, we have controllers. And controllers contain the functions that handle incoming requests and respond to the client. Finally, we have providers, and providers contain the business logic and moving parts of our project. They can be repositories, factories, helper classes, or services. Providers are reusable and can be injected directly into our controllers or into other providers. Inside our source folder, we have a main.ts file. This is the entry point into our application. We have a bootstrap function that creates a new instance of an app module. The listen function is called with port 3000, and this runs until our application is shut down. The app module that we see constructed here is the root module of our application. All of the modules we create will sit beneath it. Here we see the app module is a simple class with the module decorator added. The module decorator specifies the components that will sit within our app module, controllers and providers, and the imports array will contain a list of child modules that we'll add later on. The app controller is a class with the controller decorator added. There is no root name specified in the controller, so this will respond to requests on the root of the application, in this case localhost. We have a constructor with an app service parameter. At runtime, Nest will inject the app service type specified on the app module. Next, we have a getHello function. This also is decorated with get, has no root name, so will respond on the root of the controller. GetHello calls the getHello function on the app service. Finally, we have the app service. This is a class with a single function that returns a string hello world. This is the message that we saw in our browser. Notice this class has the injectable decorator. This means that Nest will inject this type into any constructor that requests it using dependency injection. The best way to learn any new framework is to use it. So let's get our hands dirty and make a couple of small changes that will turn the generic hello world message into a personalized greeting. First off, we'll modify the app service getHello function to accept a parameter, name, that will be a string. Next, we'll change the fixed hello world string to a template literal so that we can return a greeting customized with a name parameter. Now, back in the app controller, we'll add a query parameter to the getHello endpoint function. We'd like the user to be able to pass their name in the query string, and Nest contains tools to automatically deserialize the query string into a usable object. First, we'll add a new import to the top of our file to make the query decorator available in our code, and then we'll add it to the query parameter in getHello. This will tell Nest to take the query string and add any parameters to the query object. Finally, we'll update the call to the app service with the name property on the query object. This will correspond to the parameter called name sent by the user in the query string. Run the project with nest start, head back to the browser, and let's add a name parameter to the URL. We see that our Nest API has returned a personalized greeting by passing the query string into an object and then sending the name parameter into the getHello function on the app service. In the next video, I'll show you how to get more advanced with your CLI usage and controller functions by building a simple to-do list API that returns a list of tasks as a JSON result and allows you to filter tasks by ID. If you enjoyed this video and found it useful, then please do drop us a like and subscribe if you'd like to see more videos like this. Thank you so much for watching, happy coding, I will see you next time.